Let's discuss now how we quantify how large an angle is. So there are two different measurement systems for measuring an angle, degrees and radians, and we'll use both in this class. Now, in order to define what a degree is, the first thing we'll define is we'll say, okay, here is, let's make this bolder. Here is the initial side of an angle, and let's say we go all the way around so that the final side is the same as the initial side. Now, you won't be able to see exactly because they're lying on top of one another, the initial and terminal side. So you won't be able to necessarily distinguish between the two, but both the initial and terminal side are on top of one another, and we have gone one full revolution. So the way that we define what a degree is we say this one full revolution, the measurement is 360 degrees. As soon as you define one full revolution to be 360 degrees, you can visualize many other angles. For example, if you only go 1/2 of a revolution, then that should be half the angle measure, so that should be 180 degrees. Let's go ahead and sketch some of these. So we're going to sketch 4. So I'm going to go ahead and put 4 different axes on here. And while we're here, another thing that I'll remind you all of is what are the names of the quadrants. So because this will come up very often. So quadrant 1 is the upper right quadrant. Quadrant 2 is the upper left. The lower left is quadrant 3, and the lower right is quadrant 4. I'm not going to draw all the names of the quadrants in each picture, but I'll put them here. And typically, if I want to abbreviate, I'll just put Q1, Q2, Q3, and Q4, Q standing for quadrant. So we just established here that an angle that goes halfway, I know I'm starting with not the first one that I've drawn, but there's a reason for that. So initial side on the x-axis, positive x-axis, and final side on going the exact opposite direction. So this angle here is 180 degrees. And so half of that would be 90 degrees, so we can go ahead and visualize that. So here's my 90-degree angle. And if you go 90 degrees 3 times, then you end at the negative y-axis here, and 90 times 3 is 270. So go ahead and draw this angle here, and this would be a 270-degree angle. And of course, for completeness, let's go ahead and sketch the last one. This looks to be a little tilted. All right, fix that. And our 360-degree angle is just the one which has the same initial and terminal side, and you get there by doing one full revolution. Now these 4 angles have a name. They're called the quadrantal angles. And for basic visualization of different angles, it's important to have an understanding of what these angles look like. It'll also be important that you have an idea of what the angles look like that are fractions of 90 degrees. So, for example, I'm going to clear a little room in this first picture. If you go 1/2 of the distance to 90 degrees, then that angle, of course, is going to be 45 degrees. And continuing on another sheet of paper, It's also important to have a visualization of what it looks like to go 1/3 and 2/3 of the way to 90 degrees. So 1/3 maybe looks something like the following. There's the initial side, there's the terminal side. So this angle here, 1/3 of 90 is 30 degrees, so this would be 30. And if I wanted to go 2/3 of the way to 90 degrees, that might look something like this. Just try to double what this angle 30 degrees looks like. And if you double 30 degrees, you get 60 degrees. And we'll end this discussion just by reiterating that knowing what 30, 60, 45-degree angles look like, along with the quadrantal angles, what they look like, is critically important for visualizing other angles.